In today's video, I would like to introduce you a very nice problem of Indian Mathematical Olympiad edition 1990. Here is the following setup. Find all pairs x and y as non-negative integers such that we have this following equation involving x and y. So we have xy minus 7 quinary square equals x square plus y square. In fact, this is very nice and straightforward problem. So maybe there is a bunch of ways to solve this one. Just I'm going to do the way of the factorization. So the first thing that I'm going to mention here, we have a nice symmetry here because we have this product xy, we have this sum x square plus y square. Okay, so since we have this symmetry, we are going to assume one of the variable is smaller than the other one. Okay, so without loss of generality, assume x is inferior or equal to y, which means we can divide this one into two cases. Maybe we have x equals y, or x is strictly inferior than y. Let's consider x equals y. If x equals y, so by replacing this information into this equation, so I'm going to transfer this equation in terms of x. So which means I get x square minus 7 quinary square equals 2 times x square. Since both terms are positive, I'm going to apply the square root on both sides, which means I get x square minus 7 equals square root of 2 is multiplied by x. So if you take a look at this term, this is positive integer, but the right hand side of this equation is not integer, which is contradiction. Which x not equals to y, which x different than y. So which means x is strictly inferior than y. So I'm going to save this one for later. Now I'm ready to solve this equation. By distributing the left hand side of this equation, I get xy square minus 2 times 7, which is 14xy, plus 49, which is 7 square, equals x square plus y square. Okay, like this. If you take a look at the right hand side of this equation, it's uncompleted square here. So in order to complete this perfect square, I'm simply going to move over one of the two xy to the right hand side of this equation. So I will get here 2xy. This one becomes minus 12xy. So this one, it becomes xy minus 6 quinary square. If I'm going to distribute, this one is given as x square minus 12xy. If I'm going to distribute, this one is given as xy square minus 12xy, which is good, plus 36. But we have 49 here, which means we are going to add 13. Plus 13 equals xy quinary square, because this one is a completed square. I'm going to move over this term to the right, which means I get 13 equals x plus y quinary square minus xy minus 6 quinary square. So if you take a look at these two terms, we have a difference of two squares, which means we are going to factor out this one on the form of the product. So is given as x plus y minus xy plus 6 factor x plus y plus xy minus number 6, like this. Okay, so I have ended with this nice factorization. So the nice thing here, we have number 13 as a number, which means we have only two possibilities. So first possibility, I get number 1 equals x plus y minus xy plus number 6. The second equation, I get 13 equals x plus y plus xy minus number 6. Okay, I've got 1 plus 13, which is 14. I get 2 times x plus y. This one 0. This one also is 0. 6 minus 6. So by dividing both sides by number 7, I get x plus y equals 7. I have ended with this equation. So I'm simply going to take this found fact and insert it into the second equation. So which means I get 13 equals 7 plus xy minus 6. So which means xy, I'm going to move all the numbers to the left. I get 7 minus 6, which is 1, 13 minus 1, which is 12. So I have ended with this following a relationship between x and y. I get the product xy equals 12. Okay, now I'm going to use three things here. I'm using x strictly inferior than y, I'm using x plus y equals 7, and the product xy equals 12. Okay, I'm going to use this inequality by multiplying both sides of this equation by x. Okay, so we'll get here x squared is strictly inferior than xy. We know xy equals 12. Okay, by taking the square root on both sides, I get x is strictly inferior than square root of 12. Square root of 12 is 4 is multiplied by 3, which is 2 is multiplied. This is strictly inferior than 4. Okay, which means x is taking the following values 1, 2, and 3. Okay, then I'm going to use the first equation. Number 1 will be eliminated, because if I'm going to replace x equals 1 here, I get y equals 7 minus 1, which is 6. Y equals 6. If y equals 6 with x equals 1, we have this product equals 12, which means we get 1 is multiplied by 6, which is 6. 6 equals 12, which is impossible. Which means they're all out of this possibility. Let's move on to the second case, number 2. If x equals 2, which means y equals 7 minus 2, which is y equals 5. If y equals 5, which means I will have 2 is multiplied by 5, which is 10. 10 equals 12, which is impossible. Also, this one, it's impossible. Let's check x equals 3. If x equals 3, which means y equals 7 minus 3, which means y equals 4. If y equals 4, which means I will have 4 is multiplied by 3, which is 12, which is this one. This one is okay. Okay. So which means I get x equals 3 equivalent y equals 7 minus 3, which is 4. So I have the first solution, x equals 3 and y equals 4. But remember, by symmetry reason, we are going to take the copy of this one. I will get x equals 4 and y equals 3. Okay, let's check the obvious case. If we have x equals 0, if x equals 0, I'm going to replace this one with 0. I will get here minus 7 squared, which is 49. X with 0, we get 0 here, plus y squared, which means I have y equals 7. We are not taking the negative solution because we have non-negative integer here. So which means y equals 7. So I found the solution here. But we'll have the solution, x equals 0 and y equals 7. So by symmetry reason, I'm going to take the copy of this one as well. So I will have x equals 7 and y equals 0. Okay, so the only 4 solutions that I have here. So I have ended with this video. If you have any question or just put it in the comment section below. Don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video. Bye.